Thank you everybody for coming along to this month's Queensland AI Meetup. Second last one of the year, another one virtual. Hopefully this will be our last. I was just having a chat with Sue, CEO of the Queensland AI Hub, and we will try very hard to get in person again. I know I'm missing it. It's always good to connect with you guys in person. Tonight we have a special guest from a local Queensland, I'm going to say startup, although at this point I think they're now a little bit beyond that, a scale up at this point. But Iain can tell us all about it. But yeah, we're joined by Iain, who is the CTO at Notiv. Notiv is a company that was born actually locally here in Brisbane, or a startup spun out of Pinch Labs, which is another Queensland company. And yeah, all about taking notes in meetings, not just natural language processing, but some very cool extra features to extract structured information from meetings. So I will hand over to Iain. He can do his own introductions, and yeah, really excited for this talk. As always, if you have any questions, please put them in the chat, either the chat or the Q&A section here within Zoom, and we'll answer those along the way. And at the end, we'll make sure that we have about 15 to 20 minutes for questions at the end there. So handing over to you now, Iain. Thank you.
Thanks, Michael. Hopefully everyone can see my slides now. So today I'm going to be talking about speech and language processing in the Notiv meeting solution. I guess we'll dig into, I'll give you a bit more details about Notiv, but within that really focusing on the speech and language AI that we do within that. So I'll probably structure the talk in 3 bits. In the first bit, a little bit of background on myself and the context of AI in meetings, kind of looking back and where the current state of the world is on that. And then really digging into some of the speech and language processing blocks that we're deploying in the Notiv solution, and then end out with some final thoughts and time for Q&A. So just a quick background on myself. So as it says there, co-founder and CTO at Notiv, along with Chris Rathke, who's the co-founder CEO. So really looking back over my career, I've been working in speech and language technology, specifically in meeting technology for the last 20 some years. Really the first half of that was in academia through QUT, where I did my PhD, IDIAP Research Institute in Switzerland, where I did a postdoc and was senior researcher there for a number of years. And then back to Australia with CSIRO with the eHealth here in Brisbane, where I worked on some medical text mining and classification projects there. And around 2008, kind of had been around the academic bandwagon a few times, doing, writing papers, writing grants, and kind of been through that a few times, and was really a frustrated inventor, like most researchers in academia, I think, and really wanted to get out and make something that real people could actually use. So I launched out in 2008, had a startup called Dev Audio, which developed a smart microphone array and kind of a meeting capture application, a little bit like Notiv, and commercialized that over a period of 6 years. So went through a number of phases with that, developing the hardware, developing the software, getting go-to-market channels. And in 2014, had a successful trade sale of the company to Biamp Systems in America. They're based in Portland, Oregon, and they do what's called installed audio video market. So they develop meeting room systems around audio and video, and have all the DSP, I guess, for meeting rooms in commercial offices, right through to stadiums and hotels and airports and all that sort of thing. So they really took the microphone array technology that I developed at Dev Audio and took it to market through a number of smart meeting room products that they've developed since. And then 2018, had the entrepreneurial itch again, so left Biamp and joined forces with Chris and the team at Notiv. So we started as Pinch Labs, but have rebranded as Notiv in the last probably 18 months ago. So I just want to talk, maybe giving some context to AI meetings generally. So how can AI help in meetings. And so this is a quote from a Gartner report last year, just pointing out that AI capabilities emerging in a modern workplace can really help improve the efficiency of meetings. And there's a lot of studies out there. If you study problems with meetings or research that, you'll find that a lot of people complain about the inefficiency and the unproductive time wasted in meetings, as well as manual drudgery for a lot of tasks like taking minutes and note taking and following up with people afterwards. So there's lots of opportunities for AI to help improve the meeting experience. You'll see up the top left there at Notiv, we've kind of trademarked this term, meet better. It's about helping people, using AI to really help people meet better. So one of those studies on the problems with meetings today is this link here, the State of Meetings report. And 3 of the big problems that people report when they're surveyed with meetings say that their meetings aren't focused. There's no real clear agenda, or things go off topic, or people get diverted or distracted during the meeting. It's poor engagement, so people who maybe aren't driving the meeting get disengaged. People are there just to take notes, perhaps, and not necessarily actively engaged in the conversation, or don't feel like they've come in with a particular purpose for being there, so they're disengaged from the start. And at the end of the meeting, often the actions coming out of the meeting are unclear. So people leave thinking, well, what was that all about? And what do I need to do at the end of this? So these are common problems, I'm sure no one here is a stranger to. So where we see AI can help that is in the first one of those problems, really help bring focus. So during the meeting, to not have to worry about taking notes or focusing on capturing the meeting or thinking about the agenda, but just being able to focus on the agenda there. Being present in the meeting, again, like that. So knowing that everything's been captured so that you can just engage naturally with the people in the meeting and not worry about, being anxious about coming back to things afterwards, knowing that it's always going to be there. And then clarity. So at the end of the meeting, making sure that all the points are there, all the actions are clear to everyone, and there's a shared source of truth about what happened at the meeting and what the outcomes are. That's a record there for everyone to be aligned with, so that one of the big problems with professional meetings in particular is clients and professionals may leave the meeting with different ideas of what was agreed. So having that one single source of truth and clear actions can create alignment that saves a lot of problems and pains down the track. So just a little bit of retrospective about my own involvement in meeting technology. So from 2004, there was a project funded by the EU where I was working in Switzerland at the time. And so there was a research consortium formed of a number of research organizations, as well as half a dozen companies, that got together to really see what we could do, applying machine learning, speech technology, language technology, computer vision to improving meetings and the productivity of meetings. So back then, you can imagine it was very much a kind of a research domain. We didn't have the fantastic technology we have today, like Zoom and laptops with microphones and high definition webcams and high-speed broadband internet. So back then, we really had to pick smart meeting rooms we set up in that research project back in 2004. That's me in the bottom right corner there. And everyone in those meetings, we set about, as a machine learning researcher, I guess, the first thing you need is the data. It's hard to research and develop machine learning systems without some data. So we set about collecting 100 hours of real meetings across a range of different devices. So we fitted out these smart meeting rooms with a range of microphones, a range of cameras from close angles to wide angles, whiteboard capture device, presentation slide capture devices, smart notepads. And we collected all this data in a synchronized archive, so that we had all these different signals and sources of information throughout each of the meetings that were held in these rooms, saved and archived. And then we paid people to manually transcribe that with what was said, you know, not just what was said, but also who was speaking, and maybe gestures, and when people, you know, emotions in the room, and dialogues acts. So when people were asking questions or making decisions, where their head gaze was. So this corpus was annotated with, you know, you think of it, it was annotated for that, and it's still freely available. There's a link there if you're interested in a free public. It's a Creative Commons release data set, and it's been used in a lot of research projects and commercial applications over the last 10 years since then. And just another blast from the past, this is just a screen grab of a meeting browser that we developed at the time. So this is a prototype of, once you've got all those data sources from a meeting, what could you possibly do with that? And so back then it was kind of research projects, geeking out about the potential way, things you could extract from all of those sources, like the transcript or the speaker turns, or, you know, who's dominant person in the meeting. So we had a range of researchers pulling all these signals and metadata out of this data, and then trying to present it in an application. And this meeting browser was kind of the prototypical application for that research project. And you may see echoes of these early meeting browsers in some of the other screen grabs I'll show you later in this talk. So I guess that sets the context of the fact I've been kind of working in this area for 20 years, from when it was just a kind of geeky research problem that wasn't really practical and realizable as a real product, through to today where, you know, there are products on the market doing this. And I guess through that journey, one thing I've learned is that a lot of people focused on the transcript from a meeting. So when the meeting's recorded, they want to see what the transcript is, and that's the focus. But, you know, transcription is a key to unlock a lot of value in meeting AI, but it's not really the goal. I mean, what people want is not to relive and reread through an entire transcript or listen to an entire 2-hour meeting all over again. But what they want to do is get their jobs done after the meeting. So, you know, it's a transcription unlocks a lot of value, but it's not the goal. And a lot of what we're doing at Notiv is we don't actually do our own in-house transcription, but we are developing our own in-house AI that builds on a transcript and the audio to extract kind of higher level understanding of what's going on, and structuring that information to make it useful for people to get their jobs done. So having been in this, you know, in the speech technology for that period back in 2004, the state of the art recognition on meetings was about 60% correct. So maybe 30–40% error rate in terms of transcribing meetings automatically. And, you know, transcribing a meeting is probably the hardest automatic speech recognition problem there is. You've got multiple people speaking naturally. There's no real structure to the conversation. People interrupt each other, speak over the top of each other. There's no real control over the room. The audio quality can be variable. So really, it's kind of the hardest last frontier in speech recognition technology, is getting good performance on meetings. And from my perspective, being in this for 20 years and seeing it at the level where it was 40% error through to today, really there was a huge inflection point about 18 to 24 months ago, where, you know, since deep neural networks kind of were introduced around 2012, we've seen the state-of-the-art recognition on natural conversational speech recognition come down till it's actually now surpassed the level of human. So you can see a graph here this is showing the word error rate, so the percentage of words that were incorrectly transcribed by a computer on a telephone research data set. So this is natural conversational speech between two people. And it kind of plots how the error rate has evolved since the first deep neural network was used for speech recognition down to today. And you can see that red dotted line down the bottom, which is the human level. So if a human's asked to transcribe a meeting, they'll actually get 5 to 6% error rate in that. So really, for a gold standard transcription for a meeting, you need 2 or 3 human annotators to review and agree on an annotation. So computers today have surpassed that level, and really that's unlocked a whole lot of possibilities, such as Notiv and other AI technologies. So, you know, Gartner reported last year that, you know, you'll be familiar, we're using Zoom tonight. You know, there is the ability to record and get Zoom meetings transcribed. Teams also has the ability to get your meetings transcribed. There's other products, you know, within different conferencing products, as well as different standalone products that apply AI to meetings. And really a lot of that's been unlocked by these deep neural network advances that have got the state of the art in speech transcription to this point. So I guess that sets the context for what I want to focus on today, which is speech and language processing in the Notiv meeting solution. And like I said, we're really about building the understanding on top of the transcript, not so focused on the transcript itself, but making the transcript usable, helping people get their jobs done from that. So just a quick, I guess, a plug and overview, explain what Notiv does as a product. So Notiv connects to your meetings, captures all the details for you automatically, and then helps you curate that afterwards in one place. So it's like a hub for all your meetings. So in terms of curating, that's really where a lot of the AI happens. We help you organize and structure that information so you can act on it quickly and get your job done. And really, at the crux of this, it's not just all speech and language tech at Notiv. There's a lot of other aspects to what we do in terms of the platform, connecting to meetings, the user experience, you know, for our web product and mobile application, and understanding that. But really at the core of meetings is, you know, the real value is in their human interactions. And so speech and language technology at the heart of that is really empowering a lot of the features that we're able to deliver. So I want to maybe just, I won't go too deep on each of these, but just talk through 3 of the particular speech and language modules that we've developed over the last 2 years at Notiv, just to give you some insights into, you know, the underlying technical problems and how we relate those to a product user experience. So I'll start by talking about speaker turns, which is kind of in my area of expertise with the speech technology. So we kind of try and start with what's the user value of the technology we're developing. We don't want to just be, you know, we're doing product-led machine learning in the AI group at Notiv. So we want to be led by delivering user value, not just achieving great performance on a research task and a research data set. So really the user value that we see in speaker turns in a meeting is, 1, improving the readability of a transcript just by breaking it up in the speaker turns, makes it much more consumable. Efficiency, so having those cues in a user interface means we can quickly jump to a bit where, you know, if you're not that interested in what I'm saying now, but you want to jump forward to when there's Q&A at the end of this talk, you could visually just quickly jump to that part of a recording based on the speaker turn cues. It helps comprehension. So, you know, if you read a transcript without breaks where there's speaker changes, it can completely alter how you interpret that sequence of words. And also who said something can also change how it's interpreted based on their personality or based on their role in an organization. And accountability, so being able to tie back something that was said in a meeting or a decision in a meeting back to who said it. There's an element of value there in you know, tracing and keeping, you know, knowing who was responsible for a particular point in a meeting. So technically, as a speech researcher, I look at this problem of indicating speaker turns in a meeting. And to me, there's really 2 component algorithms we look at. One is called speaker diarization. So that's the process of taking an audio stream and then breaking up into consistent segments based on voice. So that's not necessarily identifying who the voice is, but just saying, look, from here to here, it was one voice. From here to here, it was a different voice. And from here to here, it was the same first voice again. So breaking down an audio stream into homogeneous segments, speaker clusters, if you like. And then speaker identification is then the final step of taking those segments and actually saying, well, this one here was Ian, this one here was Chris, this one was Michael. So just, I'm not going to go into equations and neural network architectures in my slides tonight, but I mean, people are welcome to ask questions at the end if they want more depth than what's presented here. But just to talk through the steps in a state-of-the-art diarization system, we take an audio signal, we take a window of that, which may be a second or 2 seconds of that. We pass it in a modern system, we pass that through to an embedding neural network, which I'm sure a lot of people on this call are familiar with, various forms of embeddings that neural networks do today. So going back 10, 15 years, this stage here would have been extracting MFCC features, so mel frequency capsule coefficients, or some linear predictive coefficients, or some other frequency bin based FFT feature. But today, basically the signal can be passed directly to a neural network, and it can be trained to learn an embedding into a subspace where different voices can be more readily discriminated. So really the output of that embedding neural network is a vector. In our case, I think it's a 1024 dimensional vector that comes out of that, and that's a space, that's a 1024 space vector that's more easy to discriminate different voices from. We pass that voice activity detection, so just a first filtering to discard stuff that's not even voice and it's just silence or noise. And then once we're left with just the voice embedding vectors, we can pass them through a clustering algorithm. So there's various clustering algorithms we could apply, like k-means would be a simple one. There's more sophisticated ones. I'm sure many people are aware of hierarchical approaches, or even k-medioids, or a range of different clustering approaches we might do. And then with initial clustering, we can segment. So we could take those clusters and then pass it through a segmentation algorithm, like a Markov model or just a temporal filter, to segment the audio into consistent clusters. So cluster 1 from here to here, cluster 2 from here to here. And often you find in a lot of these systems that are basically clustering segmentation systems, there's an iterative loop there where you can get a first clustering, a first segmentation, and use that segmentation to then improve the clustering and then get a more precise segmentation at the end. And so really on the bottom right there, you can see the output of that process is we take the audio signal that we got at the input, and now we can see from here to here, it was cluster 1, from here to here, cluster 2, then there was silence, then cluster 3, and then it was back to silence, and then person 2, etc. So if we then try and relate that to the task of identification, so one of the, the ways we've slanted this, there's different approaches to speaker identification if you look at this in research literature, but the approach we've taken at Notiv is to really use the diarization clusters to bootstrap a voice model. The advantage of this for a user is it means they don't have to explicitly go and enroll voices for different people in their organization. That can just be done naturally as a kind of consequence of the diarization. So we can take those clusters, we can use that to bootstrap voice models, and then when we get new audio with new clusters, we can compare the new clusters to the voice models and do a speaker identification match that way. So in this one, for example, we found cluster 5 in the new audio matches our model of John closely. So we can, instead of saying this is speaker 5, we can say it's John. So how that maps into a user experience. So these are some just different screen grabs of where the speaker turn information is in the Notiv product. So at the top, in the middle, you can see we've got a timeline at the top. So as part of the audio player, you can actually indicate different color bubbles where different people spoke. So you can click on those and go directly to a different speaker. So that's one way of visualizing and helping a user quickly navigate a meeting using speaker turns. So on the bottom left, you can see once we've done the diarization, that means we can present the transcript broken into speaker turns. So initially, if it's just diarization, we've got speaker 1, speaker 2, etc. So the way like I described, we bootstrap a speaker ID from that diarization. So you can click on the speaker 2, for example, and say that that's Chris and speaker 1 is Ian. And once you've assigned those, firstly, that makes it readable that transcript, this is Ian speaking, this is Chris speaking. But then in the back end, we can actually have an AI service kicked off to learn those models, associate those clusters with those people, store a voice model so that in future meetings we come back and when people go to label a particular cluster, we can automatically suggest, hey, we think this is probably Chris or probably Ian based on a voice model from a previous meeting. So that's a fairly high level view of the tech in the speaker turns within Notiv. So moving on to topics. So again, looking at the user value, again, it's readability. It helps someone read a transcript if it's broken up into coherent topic segments rather than just, one straight contiguous transcript. It helps users efficiently get to the bits they need. You know, we quickly jump to a part of the meeting that's about, if I'm interested in finance, I can quickly find, based on the topic boundaries and the keywords, go to the part of the meeting that's about that. And granularity, so this is an important thing we're thinking about at Notiv, is meetings are really a sequence of sub-meetings, if you like, different agenda items or discussions. And part of a meeting might be relevant to someone, or part of a meeting might be relevant to another meeting. And so being able to break up the, you know, a 2-hour meeting into kind of different discussion points gives us a more granular view of a meeting for sharing and relating to other meetings. So again, the component algorithms that we look at as an AI researcher view on, I look at topics on a meeting, and technically there's topic segmentation and topic classification. So a bit like speaker terms, we first want to segment it into some sort of clusters, and then we want to try and identify what those clusters are. So really, topic classification can be posed as classifying a closed set of topics that we care about, or in a less constraining view, which is what we've done at Notiv so far, just on the fly, if you like, proposing or identifying a topic based on a bag of representative keywords that we've pulled out of the actual text. So again, a bit of a high-level block diagram as to what that looks like. Similar to the speech, we take this, in this case, we take the source signal, which is the transcript, the text, pass that through an embedding. In this case, it's a text-based embedding, obviously. And again, we do this clustering segmentation process, potentially in a loop. And in this case, the output is a document segmented into coherent clusters of topics. And furthermore, we can take each of those clusters and do a separate algorithm for keyword classification or detectment terms from that, and use those as our representation of what that topic was about. So here I've just got an illustrative one where a meeting went from talking about meetings and tech into more depth in AI, speech and language, and then finished talking about user experience. So how that user in a Notiv product today. So we use that information in 2 ways. So on the left, you kind of see the homepage Notiv, where you can get a list of all your recent meetings. And there you can see we've got a few of the keywords from across those topics that help us quickly look and say, oh, do I want to look at this meeting? This one's about directors and company secretaries. I'm not really interested in that. But hey, this third one's about spectral features and absorption. So might be more interested in digging into that reading group. On the right there, you can see how we use the topics. So we basically, it's almost like chapters within the transcript. So there we've got 3 of the chapters. You can see on the right there, a little arrow icon. So we can click on that to reveal that section of transcript if we want to read the full transcript. So this means we come into a transcription of it. Instead of just seeing pages of text, we can see these top level segments and some of the keywords. And if, for example, here we're interested in digging into when this was talking about the northeast corner of this building facing the old town. Yeah, I'm interested in that because that's my new office. We can dig into that part of the transcript. So the final tech box I'd like to talk about before concluding is the action items. So action items is probably one of the most obvious things people think of when they think of, what could AI extract out of a meeting? What do I want at the end of my meeting? I want to know what the actions are for me and for the people in my group. So key user value again here is even more than the previous ones is efficiency. So if we've correctly pulled out the pertinent action items from a meeting for people, they can just not even review the meeting. Don't have to listen to it. Don't have to go through the context. They can just see that action item and share it with someone or act on it themselves. So really that can save a whole lot of time in reviewing a meeting. But, unlike a text action item, they've actually can go back in the recording and listen to the context. Who said that? Why did they say it? So they've got the full context around it if it helps them get that task done. Focus. So if I'm secure in knowing that Notiv is capturing my action items, I don't have to be taking notes and noting them down myself. Accuracy is a big one. So people think that, it's quick for humans to just note down action items during meetings, and that's going to be more accurate. But actually humans have a subjective bias view of what happened in the meeting. So what I think was an action and the reason for it and who's responsible for it might be different from what you think. And so the beauty of a automatic system is it's objective and it's, lacks that sort of bias. And also, like I said before, you can come back and actually listen to the context and get the full information behind it. And obviously, having a software system that automatically pulls your action items out of meetings means that you can just focus on your meetings, engage in your meetings, and at the end, trust that you'll be able to deliver on all the actions to your clients and your colleagues so that they trust you and view your professionalism, I guess. So technically under the hood, to deliver action items in a product, there's, again, two core technologies. One is this idea of text classification. So taking a sentence or a unit of text and classifying it against a set of labels. In this case, action item or not action item. And extractive summarization. So really, we're talking about automatic summarization of text. There's basically two families of approaches. One is extractive and one is abstractive. Extractive is when you form a summary of a meeting by actually stringing together verbatim the most pertinent parts of that meeting to make a summary. So you get the gist of it by pulling out the most informative bits of it and concatenating them. The next level of that would be an abstractive one where we actually try and rewrite and reauthor the gist of the meeting based on the content. But really, currently we're focused on producing a meeting summary for users that's formed as a list of the key extracts. So again, a high-level block diagram of how that works in general. So we take a source document, we segment that down into sentences, or in the case of a meeting transcript, there are not real sentences, they're speaking turns or speaking acts within a speaking turn. So we segment down that. Today we're fortunate that there's, I'm sure a lot of people on this call will be familiar with the range of general language models that are available from BERT and and previous ones. There's new general language models coming up all the time, and the power of these models is kind of magical almost in generalizing the language and representing it in a concise way. So you can take a segment of text, pass it through one of these language models, and then train a classification layer on the back of that basically does this binary classification. Is it an action item or not an action item? And then obviously over an entire meeting, this classification may identify a whole range of things that it thinks look like actions. So we then can take those and score them according to which ones we think are the most relevant, or filter out the noise and rank them and just present to the user the most likely actions. And then I've got there a kind of back arrow. In this case in particular, there's a great opportunity for active learning where a user can accept or reject actions that we propose to them, and we can use that in future to improve the training for our classification layer. So you can probably appreciate, a lot of developing meeting technology, like I said at the start, developing any machine learning is about having the data to start with. And I can tell you that for identifying action items from natural conversation in meetings, there is no data set for this to start with. So at Notiv, we've really had to bootstrap that, develop our own data set, and then embed in the user interface a way of having an active learning loop that can improve the quality of the action items we're suggesting over time. So showing how that maps in the user interface, on the left there, you can see, in our summary, we have a section for action items. These could be manually done by users, or they can be automatically suggested by the AI. So you can see there's a section where you can hide or reveal suggested actions. And for a suggested action, we've got a little drop-down menu where you can accept or reject. So once you accept it, that goes into your, accepted formal list of action items from that meeting that you can then share with other people. So on the right there, you can see once you've accepted an action item, it's part of the meeting summary, then you can, for example, share that to Slack or just assign it to someone else in your team within the Notiv product. So I've kind of gone through 3 of the key blocks. I mean, that's not all the the speech and language technology that we've been developing at Notiv, but I think those three in particular are illustrative of, taking underlying speech and language technology blocks that build value on top of a transcript and help a user understand that and get value out of that and quickly get their jobs done based on that. So if I can just give you an illustration of how, the impact of being able to do these things in AI under the hood in the Notiv. So, this might have looked like the Notiv product 2.5 years ago when we could record and transcribe meetings. So this is literally a raw transcript. It's actually one from the AMI meeting corpus, publicly available. And so, if we didn't have all these other tech building blocks that we add on top of the transcript, this is kind of the experience that a user would get. An audio file that they can navigate through by going backwards and forwards, or pause and play, or maybe speed up, and then just a whole wall of text, which is not easy to consume and understand. So contrast that with the current Notiv user experience on our meeting page that I'm showing here. So there you can see, if I point out here where the tech that I've shown you throughout this talk comes into the fore in the user experience, you can see there where the speaker turns is there, where the topics are there, and where the action item detection feeds in. So the net result of this is the user's actually got a really powerful way to quickly navigate to the bits of the meeting they're interested in, to review the context for a particular decision, to share part of the meeting with one of their colleagues that needs to act on things. So it's really taking an audio file and a transcript and making it actionable for getting work done. So I guess before I throw to Q&A, I'd just like to, final thought is that, working in this industry and this area for 20 years, I think I've got a deep appreciation that meetings are all about people and not technology. So, really at Notiv and in general, we're not about developing tech, but we're about empowering people. And, my personal philosophy for developing technology for meetings is that it should be ambient. It should be something that naturally understands conversation between people and gets out of the way. So, contrasting with some other meeting assistants on the market, which require you to explicitly engage with them by giving them voice commands or interacting with a user interface. Really, the technology during the meeting should be in the background and not even used by the user, but it's really before the meeting and after the meeting that the technology can help them prepare before the meeting and then afterwards get their job done. And so that's kind of a philosophy behind what we've designed in Notiv today and moving forward where we're headed with it. So I guess that ends my slide presentations.
Fantastic. Thank you, Iain. That was excellent. Great to see what's happening under the hood. We'll go through some questions now. The first one that we have is, or we've got a couple from Peter Fitzsimon. We'll put them both together. His questions are, how could this technology be applied to online meetings? Where would the capture point be? And if the audio in those meetings deteriorates, could Notiv correct for this?
So yes, it can be applied to online meetings. So Notiv today, one of our differentiations compared to other products is we can connect to Zoom, Teams, WebEx, a phone call, got a mobile app if you're just face-to-face. So our philosophy is connecting to any meeting. So there's different ways we can connect to an online meeting. So, at the lowest level, there's the ability to dial into some of them. But there's also, and that goes right through to at the top level, direct API access that some of the platforms provide, that you can get user permission to connect to their account and have access to record and access the audio stream directly. So I guess there's the answer is yes, and there's a range of ways to do it depending on the particular scenario. In terms of, improving audio quality once it's been degraded, that's kind of been my focus area through much of my career, is speech enhancement. And golden rule is garbage in, garbage out. And once you've lost information, it's hard to retain or recover it. So there are many solutions today that are attempting to recover audio quality from high noise audio or codec lost. quality from a conference call. Some of them successful, some of them sound okay, some of them don't really improve the intelligibility that much at all. So I think the answer to that is to some extent, yes, but to some extent, once you've lost information, you've lost it. So if you can get good quality audio capture and not stuff it up in the first place, that's the best bet.
Fantastic. Got a question now from Nellis. Do you train separate action item classifiers for every customer or vertical, or do you have a general model?
So I think being an early stage company, we're on a journey. Like I said during the talk, there is no data set for training action item on natural conversation in meetings. So really we're in this stage of bootstrapping a first system. So where we're at today is we've got a general model that recognizes action items from natural conversation across customers, across industries, across countries. We are definitely on a journey where increasingly adding value and accuracy and pertinence, relevance to people by customization is definitely where we're headed. And that active learning loop I talked about is a key way to get that. So understanding what someone might accept as a relevant action item to them may not be the same as someone else. Learning the vocab for a particular industry or a particular company. Yeah, so definitely there's a lot of scope to progressively improve this through customizing and getting the models more and more specific, as is the case for most machine learning models, right? You start with a general model that gets you maybe 80, 90% accurate, but that final 10, 20% accuracy is going to come from customization and matching closer and closer to your end user.
And I suppose on that note, I think at one point in there, you mentioned having custom models or specialized models for different speakers. Is that in the Notiv product? And if it is there some automated decision logic that decides when a speaker then has their own custom model trained, particularly if it's not the the user of the app, if it may be someone else who they often meet with?
Yeah, so that's, again, I've been in speech recognition tech for a while. I developed a meeting, helped, I didn't develop, I was one of a team of 20 people developing a meeting recognition system 15 years ago, and they're complex beasts. And the reality of today's modern transcription engines that you'll get from AWS or Google or IBM or Azure or a number of startups out there doing it like DeepGram, etc. They are just constantly learning and learning and learning and learning and adapting and getting better and better and better. So while in theory we can think that it will get better performance by adapting the speech recognition engine to a particular voice, the reality is all these engines are doing that just naturally through more and more data and bigger networks over time. So definitely there is potential to be doing that. We're not currently doing it in the product. We just see the tech naturally evolve and get better with people as they use it. We are definitely conscious for kind of high-end customers, companies in particular industries that might have special lexicon that they care about, like law firms or finance firms or something like that. Having on-prem solutions and being able to adapt and train a particular system that gets progressively better and better for their people and for their industry is kind of on our roadmap, but it's not a current high priority.
That sounds good. We've got a question from Daisy about extractive summarization. Were those the results from full sentences, or does it pick up the center words or label words? Are reading comprehension algorithms such as LSTMs or transformers behind that step? And does Notiv build up Notiv's own meeting corpus with domain knowledge words? Thank you.
So in terms of the action items, I mean, somewhere in there, I mentioned that speech in meetings is not like in a news article or a book. It's not broken up into phrases, sentences, paragraphs, chapters, right? So the structure of a natural conversation is, words, speaking acts, speaking turns that comprise different speaking acts. There's disfluencies, there's interjections, So at Notiv, we've actually developed our own structure for a conversation. We've got a document format there and how we parse a transcript into some sort of structure and some set of units, a hierarchy of units. And so really the action items acts, you can think of it at the sentence level, but, within a particular speaking turn, because, and speaking acts. So we've pulled out the part of the sentence where the action is, but also the context around it, so that you can understand what the action was actually about or who it was assigned to. In terms of, obviously, like anyone in AI in industry, we've got to be very careful about how we use customer data. So we use our own data for building models for the action item and learning and getting better at it. We use public resources like the ME data set as well. And we've got some I guess, early access customers that allow us to learn models on parts of their meetings. So we are progressively building up a data set and getting better at this, but it's, there's the real world side of machine learning is how do you do that while respecting trust and privacy and those aspects as well. So I hope I've answered the question there. It was a long question.
Thanks, Ian. Thank you, Daisy, for the question. Guys, if you have any other questions, please put them in. We'll get to them over the next few minutes. I do have a couple. You mentioned earlier about AWS and GCP and some of the cloud providers and their services. Yep. I've had a crack at trying to build some of my own speech models on different projects and can never quite get to the accuracy that you can get in some of these services, unlike, for example, throwing your own computer vision model together. What general advice would you have for those who are looking to tackle this sort of problem and particularly, may not have a data set with a corpus that is in the sort of topic that they're looking for or the right language? Is it better just to lean on these cloud services? And when does it make more sense to try and build your own?
Yeah, so I mean, it depends on your motivation, right? So in Notiv, our motivation is to deliver a good product, a great product to users as quickly as we can. So for us, it hasn't made sense to this point to develop our own speech to text engine, but the approach we take is we've got our own meeting corpus, and which has real meetings across Zoom and mobile capture and different audio qualities, different accents. And we run that through a benchmark task against half a dozen different transcription providers. And so every month we're benchmarking who's the best now, because my belief is that's going to change month to month or year to year. Who's leading the state of the art kind of depends. Is
that what you found?
Yeah, and so we've actually, without telling you all the details, we've been through 3 different transcription providers, and that's been completely informed by this objective process that we've developed of, got a data benchmark, we run against them all at periodic intervals, and then we select the best and deliver that to our customers. So that's kind of how we're mapping the curve at the state of the art and making sure what we deliver to customers is always the state of the art. I think if you are interested in building your own just to understand the tech, I would say that the systems are getting simpler and simpler, which is the case in a lot of this AI stuff, right? We've gone from systems that used to have to take a signal, extract some hand-coded features, pass it through different neural network architectures, and then post-process it through different things. And today, I think a lot of the state-of-the-art speech text are actually direct input-output neural net, audio in, text out of a monolithic neural network. So I've actually got a friend who develops a speech recognition system at Facebook, and I think they've released, as far as I'm aware, they've released this. I'm trying to remember the one it is, speech to text. I forget the. Sorry, I'm distracted trying to remember the acronym, but it's one of these 2 text libraries. So you can actually probably get the code on GitHub for a relatively state-of-the-art speech text system. But as you alluded to, the magic is in having the data, and there's no way Facebook or Google or Microsoft are going to release the reams and reams and reams and reams of data that they've collected and annotated over the years, because that's where their value is. So if you want to do it yourself, stick to simple tasks, I guess, and build up from there.
Interesting. And looks like we don't have any other questions, so I'll ask one final one. You mentioned in there, it's the idea of taking speech and getting to a structured representation of what happened in the meeting is a multiple stage process of speech to text, then using language models to extract that key information and sort of classifying it. If you look forward and think about this becoming an end-to-end process, because I guess there's a lot of information in speech, such as intonation and pitch and things that you may not pick up on when it's transcribed. If you had a crystal ball, when do you think that we'll be moving towards, a more end-to-end system? And what do you think stands in the way other than just copious amounts of data?
Sorry, what do you mean by a more end-to-end system? So something that's just put a meeting in and you get the full rich markup?
I suppose so, yeah. Being able to go from audio itself and also being able to infer, I guess, deeper meaning based on pitch and intonation rather than just the words themselves.
Yeah, so I think, back in my academic years, really the multimodal problems were ones that interest me the most. So the ones where you've got some information in the speech itself, as well as the text, as well as the vision, right? So you can infer, so let's take sentiment as an example problem. If we're trying to classify sentiment in a meeting, we've got cues in the prosody, like you said, in the intonation of the voice, in the pitch, the speaking rate. We've got cues in the actual words and what I said. We've got cues in just understanding who I am, how I speak, what's my normal, what things do I normally say, what's my normal language model look like compared to this particular example. And there's also information in the visual. So what's my face doing? What are my hands doing? And so there's, I guess the answer is you can go as deep as you want into a lot of these problems, right? There's information across multiple modalities and to really get the full rich information to understand the interaction from a meeting. So I think there's a long way to go before we've got kind of an end-to-end. Throw in the audio and the video from a meeting, and maybe all the, if you could look at a universal system for this, what would it look like? You get all your source information, which could be documents, your calendar events, who was attending, the names, the people, organizational chart, the audio, the video sources, what they captured on the whiteboard during the meeting. So there's all these potential sources of information. And then on the output, you really want to know, what was that meeting about? And, I think we've got one approach as to how we're developing that by, you've seen a bit of it today, breaking up a meeting into parts, and then within those finding key moments. So, that's kind of a way we're approaching it as a universal problem. So everything we look at, how do we break up the meeting into coherent bits, and within those find the key bits. And so that's kind of how we're kind of generalized philosophy to the problem, but still a lot of fun to be had developing stuff like this for another 10 years, I'm sure.
Sounds good. Well, hopefully the prototype's ready next year, so can't wait.
Yeah.
I think,
Always
that's all the
prototyping
questions.
and developing and advancing, but I should just ending, the product's available. People can just sign up for free and try it out and let us know what you think. And also, you mentioned earlier, if I wanted to give a plug for the company, we're always, we've got an AI group in Brisbane, looking at speech and language problems as well as other developers. So always on the lookout for good talents. We don't have particular posts at the moment, but opportunistic if people are really interested in this area and experienced and want to reach out, we're always happy to make connections to people in the Brisbane and Queensland region.
Perfect. Awesome. All right. I think that is it. Thank you, everybody, for attending and for your questions and engagement. Iain, thanks so much for your time putting all this together. Looking forward to hopefully catching up at some point in future, both with you and everyone else in person. I'm going to go away and try and line the next one up for the end of the year in person, so we'll see how we go. But thank you, everybody. Have an amazing week. We'll see you at the next one, and yeah, see you later.